welcome to my channel. And if you have not subscribed yet, please do so as we jump in straight to the question. This is the question we have for today, and then we have a packaging engineer is given a square carbon paper, of size 60 by 60 centimeters to design a maximum possible box to store banana fruits. The box is closed at the bottom but open at the top. What should be the dimension of the box? Now, this is a question we have to take our time to analyze. There are some key words in the question which we have to take note of. A square carbon. Yes, I hope you can see my lighter. 60 by 60. That's the maximum. And then we have maximum possible box. We are also given in the second that it is closed at the bottom, open at the top. So we have these 5 keywords in the question which we have to pay notice to, which we have to take into consideration. The 60 by 60 will give us the total material. The square is telling us that it's a square meter. So when we multiply by 60 by 60, we get the area of the square. The maximum is telling us the maximum volume the box we take can contain. That is the volume of the box, the maximum volume, not the minimum, the maximum volume. It means the highest amount of banana it can contain. Yes, that's what we want to look at. So let's jump straight and see what goes on to the solutions. Please, if you have not subscribed yet, please do so. Now I want to try and draw the box for you. This is it. This is the box I'm talking about. The down close, we open the top. This is the box we are talking about. So the down is closed and then we open the top, and then we have the total material available. The total material available is what? 60 by 60. That's 60 times 60. That gives us 3,600 centimeters square. This 3,600 centimeters square is the total material, is the whole material that was given to us. So this is the material we have in hand, and that's what we are going to use to produce the volume, to produce this box. Now the volume of the box, which is a cuboid, is given by what? Height times breadth times height. Now you can see that this is a square base, so we have what? Height times the bases, which are the x times s square, s times s, which gives us what? S square. That is why we have what? H s square. Now where h is the height and s is the size of the square bases. So I hope you understand this one, where we get the s square from. It is s times s, which gives us what? S square. So like length times breadth times height. So that gives us what? X times x is s square times the h, which is this, and that is how we get this s square. Then we have the total surface area of the box. The total surface area of the box is what we are coming to look for now. Now pay attention very well to this part, how we are going to get the total surface area. Now there are some key parts of these equations that we also have to highlight and keep and take note of them, which are these ones: the volume, the area of the base, and then the 4 times the area of one side. So we have to take note of that. Those keywords, they are very, very important. We have to take note of them. Now the total surface area is the area of the base. What is the area of the square? The area of the square is what? This side times this side give you the area, right? That is x times s, because all the sizes are equal for a square. That gives us s square plus, to get the total surface area, we have to add it to what? The size of the area of one of the sizes here times 4, because the sizes are 1, 2, 3. One side is here, and then the 4th side is here. So if I take the area of this one and multiply it by 4, I get the area of this one plus this one plus this one plus this one, and that's what is here. 4 times x, which is what? X is here, the base, which is already x. We all know that here is x, the base is x. Then the height, which is this part. I hope you are paying attention, please. And then the height, which is here, h. So that gives me the area of this part. So if I add the area of this plus the area of this plus the area of the other side plus the area of this side, it's going to give me 4 times what? The area of one side, and which is here. Please, I hope you are okay with this part. If you are not okay, you can you can replay the video and go over again, then you get it very well. Now the total surface area which we have been given, which is here, the total material which is here, that's the total surface area. When we finish forming the box, all the material will be used and all the material will be the box. So that is the total surface area of the box. That's the total surface area. That's the total material that we have, and that is equal to this, which is here, which is here. This is it, which is here, which is here. So we have 3,600, which is equal to this one. So we are going to just simplify and solve h. We are going to make h the subject from this equation, and the reason why we are going to make h from the subject is that we want to look for volume. So we want to solve in terms of one variable and not of the two variables. So we want to make the height the subject from this equation. So if we solve and we simplify the height from this equation, we are going to get this. The height to be equal to what? 3,600 minus s squared over 4x. Please, you can pause the video here and try and see whether you get the same solution, the same answer as mine over here. Then we simplify, we substitute this, and then we simplify again. So we substitute this equation into this one. Please, I hope you can see it, to this one. So wherever you see h, you are going to put what? 3,600 minus s squared, all divided by 4x. You put it here, and that gives us this equation. This equation. So we have 6,000 minus 3,600 minus s squared over 4x. Sorry, there's a mistake here. Let me just do it quickly. This place is supposed to be squared. I don't know whether you can see my tool well. It's supposed to be squared. There's a squared here, so it's supposed to be squared. Sorry. And then if you simplify this equation very well, will come out with this one, which is what? 900x minus 1 over 4s cubed. And then we further, when we simplify, we get this one. Now this is volume in terms of what? Only one variable. It means that it must have what? A domain, and the domain should not be what? Less than 0, or should be greater or equal to 0. That is the domain. So we have to solve this quadratic, this inequality here, and when you do that, you get the domain to be 0 and 60. That means the x will lie between what? 0 and 60. That will be the domain. So have to be, you can pause the video here and try to simplify this inequality and see whether you get the domain to be this. Anyway, it's not really part of the question, but I just want to let you understand what you are really going to do at the next part of the video. So we are going to take this volume, and then what? Differentiate it, because we are looking at what? The maximum. I told you that you should take note of the other words from the beginning of the question. So we are going to take this v, differentiate. So dv dx, when we differentiate, we get 900 minus 3 over 4 s squared. Please, I hope when you differentiate, you get the same thing. Please, you can check it for me. And then since we are looking for the maximum, at the maximum we equate it to what? To 0. It means you can equate it to 0. We equate the whole equation to 0, and then we simplify and solve for what? X. When we simplify and solve for x, then we are going to get x to be what? X to be what? 20 root 3. So here we multiply 2 by 4, we divide by 3, and then we find the square root of 120, and that gives us what? 20 root 3. That is what? The x, which is the dimension of the what? The square, the base square. It means we have to look for what? The h, which is this one. We have to look for h, because we are looking for the dimensions. Therefore, what do? We substitute this x here into what? The h over here. We substitute this h into the h, and that brings us to this place. That gives us 3,600 minus 20 root 3 h all over 420 root 3, and that's it. And then when we simplify this one further, we get what? 10 root 3, which is what? The dimension for the height. Therefore, to get the dimension for the, that's it, boom, it just pump up. This is the dimension. The dimension for the box will be 20 root 3 times 20 root 3 times 10 root 3, which is what? The height, or let me say length times breadth times height for the dimension of what? A cardboard or a box. How I would say it, anyhow you say it. So that is a square at the base. That's why we had this being the same, and then the height. So that's it. So these are the dimensions. Please, if you have any challenges, if you don't understand something, if there's any mistake and you want to correct any comments, you can put it in the comment section, or you can just email me, or you can also go to my other channels and let me know, so that I'll do same. If you have questions which you want explanations on, you can as well as put it there, so that together. Thank you. Please just subscribe for me, and I'll see you next in the next video. Thank you.